Today, I'll be talking about a new uh, channel standard for Landmark that's being adopted. This is a bidirectional, high-speed, IP-based, highly secure communication over power lines. Well, actually, over any wire. It could be power lines, it could be coax, twisted pair, phone lines, so on and so forth. So quickly, I work for Megachips. I've been with them for about 4 years. I handle the business development and marketing, and I've been working in the high tech industry for the past 30 years. The 30 is a very important number. Shows my age. Yeah, no hair. But also, I've seen the technology grow. Uh, and what I'm talking about today is the continuation in the growth and advancement in the communication part of it. A little bit about Megachips. We are a Japanese semiconductor company. We were established in 1990. We're currently being traded on Tokyo Stock Exchange. About 1,000 employees and about $650 million a year revenue. And we have offices worldwide. We have a wide range of products. I'm not going to get into it. You can visit our webpage later. But we do have from custom ASIC products all the way to IoT and timing controllers for displays and accurate timing products. That's used in the industrial sector. So, let me get my notes straight. So, as with the proliferation of IoT and as the networks are getting bigger and more complex, and the security needs grow, and the flow of information through the cloud increases, the need for a new communication technology becomes more and more apparent. This technology not only has to address the requirements of the customers today, but also address the cost. So you can see the numbers, by 2020, 25 billion units, embedded units. It's staggering, and it's extending to many other industries, from infrastructure to security, surveillance, to industrial and retail. So, those numbers, I believe, it's going to happen. Now, when we look at when we talk to customers, and I've talked to many, what they are asking for is need for higher bandwidths, supporting larger number of nodes, long ranges, IP-based security at every node, fast response times. Also, on the non-technical side, they want it to be standards-based. Also, they want it to be multi-sourced and interoperability. And that's one of the reasons we're working with the Landmark, because they provide the infrastructure for us to get certified and certified equipment. And low cost. And again, when we look at these requirements from an end customer's point of view, we see that power line communication is a good option for them compared to the other ones. There are many technologies, as you know, from wireless technologies to legacy power line, the narrowband technologies. Now, I just want to touch a quick base on the differences between the legacy PLC technology and the new broadband technology. As you may know, narrowband technology has been around for years, maybe 30 years, 40 years. And the biggest difference between the legacy technology and the new technology, the broadband, really is in the frequency band and the frequency bandwidth. So if you look at this chart, you see the narrowband PLC operates below 500 kilohertz. In fact, in Europe, you're only allowed to work between 32 to 95 kilohertz, which is very narrow. Whereas in the broadband, it's 2 megahertz, and sometimes all the way to 100 megahertz. HTPLC that we are discussing today is between 2 megahertz to 28. So if you look at this red line right here, that shows the noise on the line. You see how the noise is 30 dB stronger in the narrowband than where we are operating. So that is one of the biggest advantages in making the technology more robust. Another one is the bandwidth itself. You know, you're talking about, about 80 in Europe kilohertz bandwidth versus megahertz of bandwidth with our technology. So what this does is really helps the data rate, allows you to add additional forward error correction methods, such as Reed-Solomon convolutional coding. Also, it helps a lot with the latency, so it is much faster. You know, with the narrowband technologies, even with the wireless, latency becomes a big issue, especially as you add more nodes. So here we have extended the number of nodes to 1024. That's on a single network. Moving on. So the key specs for HDPLC. First of all, it's an IEEE 1901 standard. This has been around, I think it became a standard about 6 years ago. Works between 2 to 28 megahertz. It's OFDM based. The transmission rate is 240 megabits at the PHY layer, but the actual throughput is about 90 megabits per second. That's a point-to-point, which is more than what's required really for today. But another thing the customers are asking is they want it to be future-proof. Some of these systems stay in the field for 20, 30 years, so we don't know what kind of requirements will come up. I remember 20 years ago, hundreds of bits was enough. Then 10 years later, they said, well, we want a few kilobits, a few hundred kilobits. So we developed the narrowband OFDM. Now they want more than 1 megabit. So with this OFDM, it gives you enough room, so if the requirements changes, we still can use the same system. Also, another important thing is that it's IP-based, so we support IPv6. Another important thing to point out is, we are supported by many international organizations, and with Landmark, we are now working on IEC standard and with Senelex. A great feature of HDPLC is the use of CMSR. This is centralized matrix-based source routing. So this technology is an ITU standard, and it was designed for large industrial networks. So the great thing about it is that it doesn't put a lot of overhead on the line, so it doesn't affect the data rate that much, which is a positive thing. But it gives you the scalability up to 1024 nodes. It improves the robustness of the network because of the mesh capability. So it automatically monitors the line, and depending on the line conditions, it changes the routing to get to the final destination the fastest and most efficient way. Um, I think I covered everything on this slide. So another big feature of this HDPLC is the ability to reuse the existing wiring infrastructure. I just heard from someone from the BACnet. They were saying that there is a law coming down the line in 2 years that buildings using more than 190 kilowatts require to have a BMS system installed, the building management system. So the ability to reuse the existing wiring, the power lines or the twisted pair that's there, even coax that's already within the building, that saves a lot of time, a lot of money. By just replacing the hardware at both ends, you can actually meet the requirements. So here, the bridging function is very important. If you have an RS-485 as an example device on the line, by using our technology, you can bridge that to power line, and then on the other side, you can bridge it to an Ethernet. And that distance could be up to 10 kilometers. So that is really the value we're selling. So this bridging function is could be between Ethernet and HDPLC, RS-485 and PLC wireless. We have customers that are using our HDPLC to extend Wi-Fi. Also power over coax and power over Ethernet. We have reference designs for all of these. If you go to our webpage, you'll find it. So this is the development we've been doing with within Lawnmark, with the Lawnmark members, Gesitech being one of them. So we have implemented the lawn running on the same chip as the HDPLC. Currently, we are doing the interoperability and certification, and so far everything is looking good. Hopefully, we'll have this in the standard within maybe a quarter or so. So within 3 months, we'll be part of the standard. For more information, the EV kits available, you can either contact Megachips or Gesitech, and we'll be happy to send you the EV kit. That concludes my presentation. Some key takeaways. HDPLC is the new high-speed wireline communication standard for smart grid supported by Lawn Alliance.